Hey everybody, welcome back to the second part of my Pixinsight workflow tutorial where we're going to be going over background extraction and color calibration. So let's go ahead and just dive right into it. Three modules I got up on screen right now are the dynamic background extraction, SCNR, and the Spectrophotometric Color Calibration modules. So I'm going to go ahead and get rid of these two modules for now, just leaving the dynamic background extraction up. We're going to want to make a few adjustments to these settings here. You'll want to make sure that you have the drop-downs activated for the model parameters 1, sample generation, and target image correction sections. Starting with the model parameters, we're going to change this tolerance here to a flat number of 10. And this shadows relaxation, we're going to bump that up to 6. And what we're doing with these two parameters here is just making sure that we have an even checkerboard pattern of samples that are going to be generated on the next step here, and that being the default sample radius parameter. So we're going to click on that and change this to 100. And this is a pixel value, as seen when you hover over the description right here. We can go ahead and leave the samples per row and the minimum sample weight at their defaults, and we're going to click on Generate. So you can see here that we generated our samples evenly distributed across the area of the image. Once those are generated, we're just going to make one more tweak under the target image correction. Under this dropdown, just click on Subtraction, and lastly, just make sure to check this middle box here, Discard Background Model. We don't need to have to worry about having a separate background image to work with. So now that we have our samples generated, we're going to want to go through each one of these to make sure that none of them lie on the nebula that we're trying to make out from the background. So with that, I like to start on the bottom right-hand corner for these samples, and in order to get there, you can click on this Select the Last Sample button. What that does is that it brings your selected sample down to this bottom right corner. You can see that it is a different color than the rest of the samples, meaning that it is selected. It can be a little hard to see, but if you're paying close attention, you'll be able to see that it's definitely a different color than the rest of the gray samples. If you want, you can change that here too, but typically I'll just leave these under defaults. So what we're going to do is we're going to go individually one by one through each of them to make sure that none of them are going to be lying really in this central area on any part of the Eastern Veil Nebula. So we can go and hit this arrow, and we can see that the selected sample is being moved. So we're going to go sequentially through all of these samples and get rid of any that might even be close to anywhere where the nebula might be within this image. I'm going to click on this X right here, and we can see that it got rid of that image. And same thing with this one right here. We'll get rid of that. And we're just going to keep going until we're confident that none of these samples are going to be on any of the nebulous regions on this image. A quick thing to highlight here is that this box right here is actually the sample that we're currently looking at. So right now I know we're pretty confidently on the tail end of the Eastern Veil right here, and we can actually see that with a lot of these blue pixels that's being picked up in the background sample. If you see anything like this, you're going to want to get rid of that sample, so that way it's not being deducted from our background when we end up running this module. All right, so I got rid of that, and once you're confident in your sample generation, we're going to go ahead and click on this new instance and drag it over to our image. Once more, we'll hit the auto stretch function, and we see that we have a nice background extracted image of the Eastern Veil Nebula. With this, we can go ahead and close out of the dynamic background extraction module, and I'm going to minimize our original image, put it down here, and let's go ahead and rename this DBE for dynamic background extraction. All right, now that we have that renamed, we can open up our SCNR module. I always leave this at default, so you can click on this to reset it if you're not confident that it's already at defaults. Once it's reset, again, same thing, let's go ahead and drag that over. And what that's doing is that it's eliminating a lot of the green noise that's left over after the background extraction. For most color cameras, there are 2 green pixels to every red and blue pixel, which oftentimes leaves this green noise on a lot of the images. This module helps eliminate a lot of that. Once that's complete, we can go ahead and close our SCNR module. Now let's move on to our color calibration for the photo after we've done our background extraction. So let's open up the Spectrophotometric Color Calibration module, and if you're unlucky like I am, when we try to run this, we're going to get an error saying that the image has no valid astrometric solution. And this is because during the weighted batch pre-processing script that we ran earlier, it was unable to correctly plate solve what our image was and where it was located in the night sky. So before we actually perform this color calibration, we're going to want to do one step, and that's using the image solver script. So let's click our image. We're going to go to Script, Astrometry, and image solver. It's going to open this box and it'll be able to get a lot of these details saved within the metadata of the images that you captured. Oftentimes tools like Astrophotography Tool, Nina, or ZWO's ASI Air, it's going to capture where and when the telescope is getting your data from. So a lot of this should auto-populate, but you will want to change your focal distance to the correct focal length that you were using on your acquisition telescope. So for this image, I had my ASCAR with my reducer in, which ends up being a 456mm focal length. My pixel size is already correct at 3.76 micrometers, and we can leave the model parameters here at default. Once you've adjusted your focal length and make sure that your image parameters are all correct, go ahead and just click on that OK at the bottom. So if you get any sort of errors during this part of the tutorial, there's a good chance that it's going to be one of two things. So I'm going to open up this image solver script again. If it errors out saying that it's unable to plate solve, I would first check to make sure that your right ascension, declination, and your date and time are all correct. Because if it's not, it's going to have a hard time actually finding your object via plate solving. If you're not confident in these parameters right here, what I like to do is just go to astrometry.net, upload my file, and then it's able to give me a lot of these coordinates here on the right side of the screen. Once you get those parameters, you can try putting them in here, plug in the date and time for when you took the image, and see if it works after that. If it's still not working, there's a chance that your Gaia star catalog isn't set up on your local system. And if you need to get your Gaia star catalog set up, I have another video here explaining how to do that. Assuming that your image parameters are correct and your Gaia star catalog is installed properly on your system, you should have no issue plate solving your image. So with that out of the way, now we have a valid astrometric solution for our image. If we go back to our Spectrophotometric Color Calibration module, we should now be able to run this. But first, let's go ahead and take a little bit more time to look at this background neutralization section. We want to make sure that we have this parameter set up properly before we do the color calibration. So first, we're going to want to find a spot on our image with little to no stars. And I'm seeing this section right about here. We're going to want to make a preview of this area without any stars in it. And in order to do that, you just hit Alt and N to get your preview tool out. And it doesn't have to be real big. Just make sure that there's no stars or nebula in there. So that's a pretty empty part of the image there. Let's zoom back out. And now under this background neutralization, we'll click on this region of interest. And then from preview. Since we just made that one preview, it should populate on this drop down. We'll click on that and then OK. It'll automatically put in those image parameters there. And now let's move up to this calibration drop down at the top here. First, we're going to take a look at our red, green, and blue filter drop downs. If you have a specific camera that you know you're using, you'll be able to select that from here. So if you have a Canon, for example, or maybe a Nikon or Sony, you'll be able to select any of those options within this drop down. With my camera, which is the ZWO 533 MC Pro. That is a Sony chip, so I'm actually going to go ahead and leave it at this Sony color sensor RGB, but I am going to change it to the non-UV IR cut because I'm not confident that the sensor in there actually has that pre-installed. I'll typically leave all other drop-downs and options to their default settings. So with that, we will apply this to the image, and with a valid astrometric solution, it's actually able to complete this color calibration now. It gives us this nice little graph if we're interested in taking a look at the more specific data, but usually I will go ahead and exit out of this, or you can actually deselect that from the module itself right here. So now we have a color calibrated and background extracted image of the Eastern Veil Nebula. I like to disable and then re-enable the auto stretch function after we've done the extraction and calibration, just to make sure that it updates after the changes that we've done. We're also able to close out this preview tab as well, as we no longer need that. And now we have our image that we'll be working with for the rest of the tutorial. In the next video, I'm going to be going over stretching the image using the histogram and curves transformation modules, as well as star removal. So that way we can process the nebula and the stars individually, giving us a lot more control over how the image looks. If you thought this video was helpful, it'd be awesome if you guys could give it a thumbs up and maybe consider subscribing. Thank you for watching, and I'll see you guys in the next one.